In this video lesson, we will learn about 30, 60, 90 triangles. So, what do we mean by 30, 60, 90 triangle? What do the 30, 60, and the 90 refer to? This is actually just a special type of a right triangle. It's a right triangle that has angles of 30 degrees, 60 degrees, and 90 degrees, which is why it's called that. So this is actually just a special type of a right triangle, and it's got a very convenient property. If its hypotenuse has length c, then its shorter leg has length c over 2, and its longer leg has length root 3 over 2 times c. So this is the main important fact about 30, 60, 90 triangles. We're going to apply it to a few examples so that we remember it better and know how to use it. So here we have a triangle, and it's got the 90-degree angle and the 60-degree angle. So that means that the last angle is 30 degrees, so this is a 30, 60, 90 triangle. So we have one side length, and it's AC, and it's equal to 3. To find the others, we label AB as length C, and then that tells us that the shorter length is C over 2, and the longer length is root 3 over 2 times C, which is also equal to 3 because that's what we're told from the very beginning. So we solve this for C because we have root 3 over 2C equals 3. And we get C equals 3 times 2 over root 3, but we would like to rationalize the denominator. So we multiply by root 3 over root 3, which is the same as multiplying by 1, which doesn't change anything. And this changes our fraction to 2 root 3 over 3. And in the end, after we're done calculating, we get C equals 2 root 3. So that tells us the length of the hypotenuse. Now all we got left is to find the length of BC, which is C over 2. So we just divide by 2 and we get root 3. So our final answers are AB equals 2 root 3, and BC is equal to half of that, which is root 3. So as you can see, knowing that this is a 30, 60, 90 triangle helps us out a lot in finding all the side lengths. Alright, let's do another example and see if we really know this. This time it's a word problem, as in there's no drawing given. So we have triangle ABC with A is 30 and B is 60. So I'm writing down the important facts here separately. And side AC has length 10. Also, if A is 30 degrees and B is 60 degrees, then C has to be 90 degrees. This is because 30 plus 60 plus 90 is equal to 180 degrees. But in any case, first I draw angle C because the 90-degree angle is easy to draw. And then I draw the 60-degree angle, and here they connect at point A. And that makes a 30-degree angle. So now we have an accurate drawing of what's going on, at least a little bit accurate. So I have AC is 10, and of course we label the hypotenuse as C, giving us the relations of the other sides, the two legs, one of which is C over 2, and the other, which we know is 10, has to also equal to root 3 over 2 times C. As before, we solve this for C. We get 10 times 2 over root 3, which is 20 over root 3, and then I rationalize the denominator. So I multiply by root 3 on top and by root 3 on bottom, and I get 20 over 3, 20 root 3 over 3, because square root of 3 times square root of 3 is just 3. So that gives us C, the length of the hypotenuse. Now, of course, BC has just length half of that, just like in the last problem. So BC has to have length 10 root 3 over 3, because we just divide 20 root 3 over 3 by 2. So these are our two answers. AB is equal to 20 root 3 over 3, and BC is equal to 10 root 3 over 3. All right, now let's just do one last example. So this is a slightly different problem. Before we try to solve it, let's at least try to make a drawing. So we have an equilateral triangle. So just draw that first. It's got 3 equal sides, 3 equal angles. And those sides have length 7. And it asks us to find the area. So how do we find area usually for a triangle? The most common formula is 1/2 base times height. Now the base here is going to be 7. The only thing we don't know at the moment is the height. So let's draw the height first. It's the line that drops down to the base and makes a right angle. And I labeled it H here. H for height. So we want to find the length of this height. And as soon as we found it, we'll have solved our problem. But note, if this is an equilateral triangle, then each angle must be 60 degrees. So I label that 60 degrees there. And now look, if I erase the other half of this equilateral triangle, then I get 60 and 90 degrees for 2 of the angles, making the last angle a 30-degree angle. And of course, the hypotenuse is of length 7. So this is actually secretly just a 30, 60, 90 triangle. And we know that the height h has to equal to root 3 over 2 times the hypotenuse. So that gives us the height h. So now all I gotta do is multiply the base times the height and divide it by 2. So I do just that. Base is 7, h is 7 root 3 over 2. And we multiply and get 7 times 7 on top and 2 times 2 on the bottom. So it's 49 root 3 over 4. And that is the area of our equilateral triangle. I hope these problems helped. Thank you for watching.